So this basic idea of finding corners in thinking about it this way, I don't know if I would say it was first introduced, but I'll say that it was most well-known introduced way back in 1988. I know some of you guys were like in diapers, and some of you were a dream in your parents' eyes, and some of you were a nightmare in your parents', no, whatever. It's a long time ago, all right? And the picture here down below is just showing you sort of a mess of corners, and they don't all look like corners, but there are places where the gradient varies. And it was created, this paper, the Alvey Vision Conference is what later I believe became the British Machine Vision Conference, and it was done by Harris and Stevens. Now, if you ask anybody about the corner detector I'm about to tell you about, they'll tell you that they're Harris corners, because that's what everybody remembers. I know an awful lot of people in computer vision. I don't know who Stevens is. So this tells you something, that if you're doing a paper with somebody, try to get your name first. Unless, of course, it's your advisor and he or she's paying for your education, in which case then, you know. But anyway, it's actually Harris and Stevens, and you can impress somebody by saying Harris and Stevens corners, but it's Harris corners. All right, so let's learn about Harris corners. So Harris corners are based on an approximation model and an error model. And here's how we do. Let's assume that we've got an image I, and right here, right? And I is the intensity image. And what we're going to do is we're going to say, if I shift that I by a little bit, by a U and a V, and I were to sum up the square over some window, how much error would I get? Okay, that's the game we're going to play. So stepping through that, I is our image intensity, so I of xy is just the original image. The U and the V is some small shift. So if I were to pick up my window and move it over a little bit, I would now get some different image, just shifted by a little bit. I subtract them and square them, and then I'm going to sum them up over some window. Okay, so the window is going to be some area around some point. So that's written here as W of xy. The total value here, E, is sort of for error. You really can think of it as sum of the change, where E for error, energy. But the idea is that we're going to sum it up around that window. Now, of course, your window can typically be a square window, like in my house. Or if you want it to actually work a little bit, or on a slow computer, you make it be a square window. But if you actually want to weight the pixels near the point you're thinking about more than the pixels that are far away, you would use a window that falls off in intensity. So like a Gaussian window would be an example. So typically, your windows can be square if you need to be really fast, or smooth if you need to be really good. So are you fast or are you good?